For today's lesson, we're going to be talking about key features of functions. We're going to have this split up into two parts. For today, we're going to be talking about domain, range, end behavior, and intercepts. So when we talk about the domain are the x values, and that means we're going to look at the graph from left to right. Now, we're going to look at it from left to right because we're looking at it from least to greatest. So we're always going to look at our negatives to our positives, so our lower values to our higher values. And our range is a set of y values, and we're going to look at that from the bottom to the top. Now, what do I mean when I say this? So when we're looking at this graph over here on the right-hand side. So when I read this graph from left to right, so we're starting right here at this x value of -4. Now remember, range is x value, so we're not going to worry about the y value. We're going to look at the x value, and we're going to define our domain of all the x values that are included in this graph. So this is a solid graph, no holes, no breaks. So we're going from -4, and even though there's some stopping points where we change direction, that doesn't change the domain. And we're stopping at +5. So I have a whole graph that goes from -4 to +5. So my domain for this particular problem, we're going to use the bracket because it is going to be included from -4 to +5. Now, when we look at our range, so if we look at this one, is going from the bottom to the top. So the lowest y value of this graph is going to be right here at -2. It doesn't go any lower than that. And yes, there's a lot going on in between. We have some changing in direction. We have some multiple values, but remember, in order to be a function, the only thing that can't repeat are our x values. We can repeat y values. So we do have multiple spots where we have y values included, but it doesn't stop until we get to +4. So our y values are from -2 to +4 in that range. So we're going to do a closed bracket from -2 to +4. And we're going to look at some more examples later, and then we're going to talk about when do we have what we call discontinuity. And discontinuity is when is our graph not continuous? When does it have a hole in it? When does it have a break in it? And then we need to talk about end behavior. Now, end behavior is basically what it's asking. What is happening at the ends of the graph? Okay, so end behavior is asking what happens at the ends of the graph. So we're going to look at how far the left side and the right side of the graph and how they're going to trend. They can either trend up or they can trend down. And I'm going to put a side note here that they can approach values. So we are going to look at some that approach actual values instead of infinities. So when we write the end behavior, so when I look at the left side, so the left side of my graph, okay, is, if I think about the coordinate plane, the left side of my graph is when x is negative. So we're going to state it as such. We're going to say as x approaches -infinity. So -infinity because we're approaching the left side. Then we know that f of x, remember f of x is the same thing as y, okay, is going to approach positive or -infinity. It's going to go up or it's going to go down. So when we read it, we say as x approaches -infinity, is how we're going to read that. Then y approaches positive or -infinity. Okay? Now, the same thing is going to happen with the right side, except for the right side this time is going to be my positive values. So we're going to the right. So x is going to approach positive infinity as f of x, which is y, approaches positive or negative infinity. Is it going up or is it going down? So again, we would read that as x approaches positive infinity. then y approaches positive or negative infinity as well. So you ask yourself, on the left side of the graph, is it going to go up or is it going to go down? On the right side of the graph, is it going to go up or is it going to go down? Now we're going to talk about our intercepts, and then we're going to kind of pull this all together. So my x-intercepts are where the graph crosses the x-axis. Now, algebraically, you find it by substituting 0 in for the y value. And sometimes that's easier said than done. It depends on what type of function you have. But the reason that you're substituting in for the y value is because on the x-axis, anytime a graph crosses the x-axis, is where y is equal to 0. So my y-intercept is when the graph crosses the y-axis, and it can be found algebraically by substituting 0 in for x. Same thing applies here. If I'm looking at my y-intercept is going to be the point where x is equal to 0. So we're going to talk about all of these things, and we're going to kind of bring them all back together. And we're going to talk about them all with different functions. So looking here, we're going to talk about the domain, range, and behavior, and the x-intercepts of these two particular. Now, I graphed these already in Desmos. You should be used to Desmos by now. If you are not, please email me, and I will send you a tutorial video on how to get started with that. But let's looking at Desmos. I have my graph here. Now, I have both of them graphed, but you can see that I have my ends are going to keep going on and on forever. Okay, and then there's some changes happening in the top and the bottom here. So I've actually screenshotted this. So I'm going to add that screenshot in here, and let's look at it. All right, let's get the right one. There we go. So looking at this screenshot, so I did click the point so that we could see them. But right here, I should be able to see that these arrows are going in opposite directions. So let's talk about the domain. So the domain in this problem is from left to right. So from the left side, okay, as I keep going down, I'm going to keep going out. So it's coming from that negative infinity sign. And yes, I have some changes in direction and some change in curvature, but nothing actually stops my graph, and it's going to keep going up and keep going to the right. So this is from negative infinity to positive infinity. Same thing is going to happen with the range. So from the bottom, we have an arrow that's going down, and it's going to have multiple y values in between here, but it's going to keep going up to positive infinity. So my range for this problem is going to be negative infinity to positive infinity as well. Now let's talk about the end behavior. So the end behavior. So we have to do two ends. So I don't care about what's happening in the middle in here. That is not what I'm focused on. What I am focused on are my ends in the graph. So I have an end here, and I have an end here. So let's start with this left side. So as I'm going to the left, my graph is going down. So as I go to the left, my graph is going down. So as x approaches negative infinity, that means going to the left, then y, or f of x, is going to go down. So if it's going down, then it's going down, which is negative infinity. That's the left side. I know it's the left side because of the fact that we said x is negative infinity. So then we have the right side. So the right side is going up. All right, so as x approaches positive infinity, we're going to the right this time, so it's going to be positive. Then my y values are going up, which is also going to approach positive infinity. Now, I'm going to write this in a different notation, especially for pre-cal. You need to know this. Going into college, this is how it's going to be notated. It's going to be notated like a limit. And that limit means that there is a limit to where my graph is going. Well, obviously, if we're going to infinity, there is no limit, but we still notate it and such when you start to talk about limits in calculus. So it says that as x approaches negative infinity, that's my left side, then f of x is going to equal negative infinity. It's going to approach that negative infinity. That's my left side. And I know this is my left side because of this notation right here. This right here is telling me that it's going to the left because x is going to approach negative infinity. All right, so if I were to do the right, so the right this time would be as x approaches positive infinity. I know this is the right side because my right side, it says x is approaching positive infinity. So then we know that the limit of f of x is going to be going up, which is going to equal infinity. So we're saying the same thing, we're just notating it in different ways. So let me make sure we understand here. So x is negative infinity, x is negative infinity. Y is negative infinity, y is negative. X is positive infinity, y is positive, y is positive. So those notations are just different, but the values are the same. Now, just because one is negative does not necessarily mean the other one is negative. Okay, so we'll see that in another example in just a second. So then I have my x-intercept. So my x-intercept in this problem, I have 3 of them. All right, so I have 3 times that it crosses the x-axis. So I have negative 0.50. I have 0.586 and 0. And I have 3.414 and 0. So 3 times it crossed the x-axis. And then my y-intercept is going to be 0, 2. All right, so back to this example. You can screenshot however you want to if you're filling out the interactive notes. But for the next example, I also put this one into Desmos. All right, and for this example, I'm going to turn that one on and turn it off. We can see that this time the ends are doing very different things. They're both going down, so obviously my end behavior is going to be different as well. So I'm going to go add this graph into our notes. All right, so in this particular example, so let's start with the domain. All right, so my domain this time, remember we're going to read that from left to right. So we're going to read it from so we still have arrows down here. So from the left, we're still coming from the left side. Yes, there's some changes in curvature and direction, but we're going to continue to go to the right with nothing stopping me in between. So we're going to go from negative infinity to infinity. Now my range is my y values. So my y values this time, we're coming from the bottom. So we have arrows, and then there's some multiple y values in between, but the highest y value that we are going to approach is right here. We're not going to keep going to infinity. We're going to have to stop at a value for this y, which is going to be 5.848. And we're going to put a bracket there because it is a closed circle, which means that y value is included in the graph. All right, so now let's talk about the end behavior. So we have 2 ends. So we're going to start with the initial notation, then I'm going to put it in limit notation. So my end. So as x, so this side goes to the left, it is going to go down. So as x approaches negative infinity, y, or f of x, is going to approach negative infinity. All right, so my right side. As my right is this time, my right side is going to go down instead of going up. So as x approaches positive infinity to the right, then my y value, or f of x, is going to go to positive infinity because it's going up. So if I were to write this in limit notation, we would say as x approaches negative infinity, that's the left side, then my limit of the function f of x, y, is going to approach negative infinity. That was the left side. So the right side, as this time x approaches positive infinity, then my f of x, or my y, is going to approach positive infinity. So you're still putting the same values, you're just notating it in a different way. And then we have our x-intercept. All right, so my x-intercept, I have 2 of them this time. So I have negative 2.50 1.0520 at 1.448. And then my y-intercept is going to be where it crosses the y-axis, which is going to be at 0, 1.